So here is a quick recap of some of the things that we have learned so far in Algebra 1 and in Algebra 2. But these are the key concepts. Without learning them, without understanding them and knowing them, and quite frankly memorizing them, we will not be able to succeed in our journey of Algebra 2 and then beyond to pre-calculus and calculus and so on and so forth. So when we're talking about polynomials and especially solving polynomials, it is imperative that we understand that there are several different factoring techniques, and two of the most important things that you have to remember when we're trying to factor polynomials and solve polynomials by factoring is the sum of two cubes and difference of two cubes. This is in addition to the sum of two squares and the addition of two squares, which we're going to see on the next screen hopefully. But when you have sum of two cubes, it means that we have a cubed plus b cubed, and what this gives us is that it gives us a plus b. The sign right here, it follows, right? And then it jumps to the end. And so that's how I remember it. So we have a plus b times a squared minus ab plus b squared. That's what a cubed plus b cubed give us. That's what happens if we have it in the factored form. If I multiply it out, this is what I would get. So if I multiply a plus b times a squared minus ab plus b squared, I would get a cubed plus b cubed. Similarly, we have difference of two cubes. Sum means addition or plus, difference means subtraction. Alright. So if I have a cubed minus b cubed, this is equals to a minus b times a squared plus ab plus b squared. Alright. So here we had a minus and a plus, here we have a plus and a plus. The only minus we get or subtraction we get, it follows from the a cubed minus b cubed. So it's kind of easy to remember. Let me give you a few minutes to copy this down, and then I'm going to pause the video here, or you can pause the video here, and then once you're done taking notes here, move on to the next screen to look at some more key concepts. Alright, I hope that you were able to take notes on the key concepts. Now let's look at some factoring techniques. For a polynomial, you have to first look at, you have to observe the polynomial and you have to ask yourself, what does this polynomial look like? Alright, what does it look like? And so if it's just a normal polynomial, then you're going to have to figure out the greatest common factors, which means you have to take out terms, most a's and b's, most powers from each term as possible. Right? So for example, here we have a to the fourth in this term. In the second term we have a to the 1. So what's the most a's that we can take out? We can take out a to the first power or 1 power. So we took out a to the 1 power. Well, that left us with a to the 3, which is right here, but there was no a left over in this term. So we can see that there is no a left over here. But if I multiply this 3 back into 2ab, I would get 3 times 2, which is 6ab, which is right here, 6ab. So greatest common factor is a technique that is used extensively when factoring polynomials. And why are we factoring it? Well, we're factoring it, remember, because we can say that if we have two things multiplying, then either this has to be 0 or all of this has to be 0. Okay? That's why we factor things, so that we can set them equal to 0. Factors multiply. When two things are multiplying to give you a third thing, those two things are called the factors of that third thing. Alrighty. When you have two terms, when it's a binomial, like a squared minus b squared, or a squared plus b squared, or a cubed plus b cubed, or a cubed minus b cubed, then we can use the difference of two squares, sum of two cubes, difference of two cubes. So there is no general term general factorization for a squared plus b squared. Right? We don't have two factors that multiply to give us a squared plus b squared. If I try plus and plus, then I get a squared plus 2ab plus b squared, which is incorrect. That's not right. If I try a minus b times a minus b, then I get a squared minus 2ab plus b squared. That's incorrect as well. And if I try a minus b times a plus b, then I'll end up getting this difference of 2 squared, a squared minus b squared. So general factorization for a squared plus b squared does not exist in real numbers. Alright, so we only have difference of 2 squares, and we have sum of 2 cubes, difference of 2 cubes, we have perfect square trinomial, and then we have general trinomials where we take out whatever we can, and we hope that we can come up with something that can make some sense. And then another technique that's used is called grouping. We use grouping a lot to group things together. We'll see some of that today as well. All right, so let's get ready for some examples.